right, so here we are with the, not 10-3 assignment, the notes from 10-3. Fold this here. All right, so today's 10-3 notes is about composite figures. Basically, the main idea is that you are going to take these figures that may look not like a normal shape, and you're going to break them up into pieces. So, our official definition of a composite figure is made up of simple shapes such as triangles, rectangles, trapezoids, and circles, and you're going to use those simple shapes to find the area of a composite figure, which is to find the areas of the simple shapes within that composite figure and then use the area addition postulate. The area addition postulate just means that you can add areas together. All right. So, of course, there are many ways that we can make these figures into composite figures, especially if you remember back to our first example of the tangrams idea. I could, break this up into a triangle and another triangle and maybe another one and throw some circles in, but the idea is to do it in a way that is as simple as possible. So, in that case, in order to figure out the area of this composite figure, perhaps you're looking at it and saying, okay, well, let's make 2 rectangles. So if we kind of cut it off right there, we have a rectangle here on top, which is 15 by 12. And then we have a rectangle on bottom here, which is 27 by this unknown length here. You could have also cut it here, okay, and made a rectangle here and then had a 15 by 21. But again, you still would need to find out what this length is. So on that note, to find this length, notice that the entire height of this shape is 21 centimeters. And this little piece here is less 12. Okay, so in order to get this side length, we're going to do 21, take away the 12 that's already this top half, and we should be able to get this bottom part here. So that means that 21 minus 12 is going to get you 9. And so this is actually 9 centimeters. All right. So as we do that, again, the area of, I think we'll just number them here. The area of figure 1 and figure 2 will be added together from the area addition postulate. So the area of number 1 is going to come from base times height. In number 1, our base is 15. It doesn't necessarily look like it's 15, but across from it here is 15. So the base is 15, and the height is this side over here, 12. And so 15 times 12 is going to be the area of figure number 1. So 180 centimeters squared. Okay, then to find the area of shape number 2, which is also a rectangle, we use our formula for an area of a rectangle, and now we're going to do our base, which is 27, times our height, which is 9. And so 27 times 9 leaves you with 243. Okay. Of course, that is not the answer. You're looking for figuring out what the total area is. So we're going to go ahead and use the area addition, meaning we're going to add them together. And so 243 plus 180 is going to result in 423 total centimeters squared. And so there aren't necessarily specific formulas for each of these, but there are formulas for each of the pieces of these. All right. So the next one here, if you kind of took out these dashed lines, we were just kind of trying to find this rounded triangular shape here. But in order to find the area, we are going to kind of use these dashed lines that are given. And let's see. All right, and we are going to, we can break it up into 3 pieces or 2 pieces, and I do not like so much work, so I'm going to break it up into 2 pieces. So to kind of follow along here, this piece here, instead of talking about it being a rectangle, if I combine it with this triangle that is up above, I actually have a trapezoid. So here's shape number 1, which is a trapezoid, and then we have shape number 2, which is half of a circle. Okay. So the problem with both of these is that we are going to need to know the distance between these two sides. It would be the diameter for number 2, but it would be the height between the two bases in the trapezoid. So in order to figure that out, we are going to kind of make a side problem here of that right triangle that's on the top. So that right triangle on the top has a hypotenuse of 10.2. It has a length here that we are trying to find. And then it has a height of just this part of the triangle. And this part of the triangle height is going to be the result of 7.8 minus 3. So 7.8 minus 3 is 4.8 for the height of this triangle. So in that case, 4.8 goes here. We do know that this is a right triangle from this little square that was down here. And so we're going to use Pythagorean theorem in order to find the distance between these two. So Pythagorean theorem says go ahead and label your hypotenuse as C. The other two legs can be A or B. And so A squared plus B squared is going to equal C squared. A is 4.8. Go ahead and square that. B we don't know, but it is X. And C is 10.2, which we will also be squaring. So 4.8 squared results in 2304. Add that to X squared, and it will equal 10.2 squared. And that's 104.04. And so now we'll subtract our 2304. And we'll have X squared equal to 81. As we solve this, we're going to take the square root of both sides, and we'll end up with an X of 9, which means going back to our picture, we have a height between these of 9 feet, or diameter. All right. So in order to find the area of shape number 1, that's a trapezoid, and so we'll use our area formula of base 1 plus base 2 over 2 times height. All right, so as we fill this in, your base 1, we're actually kind of looking at it like this. So your base 1 is 7.8 feet. We'll add that to our other base, which is 3 feet. Divide by 2, and multiply that result by the height, which we just got, which was 9 feet. In order to solve that, of course, we don't want to do it all at once. You do want to do the numerator first, so 7.8 plus 3, which is 10.8. Take that number, divide by 2, and then multiply by 9. So 10.8 divided by 2 makes 5.4, and that's going to be multiplied by 9. And so 5.4 times 9 makes 48.6. And we do have feet squared. So that's part of the shape. The other part of the shape is this half of the circle down here. And so to find the area of number 2, we're going to use the area of a circle, but then we'll divide by 2. So we have pi r squared as the area of the circle, but we'll divide that by 2. Our radius is half of 9, so that means that we are going to have pi r squared, or pi 4.5 squared, divided by 2. And so that means that the area is going to be 4.5 squared, but times pi and then divided by 2. So we're going to have a result of 31.81. All right, so that means that in order to find the total composite figure, we're going to add them all up. So the total is going to be taking the 31.81 and adding it to the 48.6. And so we'll be left with 80.41 feet squared. All right, so kind of a lot of side problems on that. Moving on to the next example, this one says find the area of the composite figure by subtracting. So instead of thinking of this as 2 shapes or 4 or however many you want added together, we're going to actually think of it as a rectangle that we are subtracting this triangle from. So again, the total area is going to come from the area of number 1, which is this kind of solid shape here, but then we're going to subtract the area of the second part, which is this triangle on top. All right, so the area of the entire shape here is going to be a rectangle, and so in that case we're going to just have base times height. The entire bottom shape here has a base of 36 and a height of 18. And so your result of 36 times 18 is going to leave you with an area of 648. But then from that, we're going to subtract the area of this triangle. And the area of a triangle is half base times height. So our base, which isn't necessarily drawn, is 36 because it's the same from one rectangle to the other. So it's going to be a half base of 36 times a height of 9. And so that means that we are going to take half of 36, which is 18, and multiply by 9. So 162 is the area of the triangle. And then our total area, again, is going to be taking 648, subtracting 162. And so it's 486 meters squared. All right. So again, looking at this one, we were trying to do subtracting. You could have done adding. You could have had a trapezoid here and a trapezoid here. You just would have had to find a few more measurements. So that's perfectly fine. The last example that we're going to do here is another subtraction. So we have a rectangle here of 33 by 16, and then we have 2 halves of a circle, which technically means that we have an entire circle. So if we imagine that we take out this circle and move it over to this side, we in fact have an entire full circle. So in order to find this, we are going to find the area of the rectangle. That's our first shape. And then our second shape is the circle. And so our total area comes from the area of rectangle 1 and subtract out the area of the circle. So the area of the rectangle is going to be base times height, and the base is 33 and the height is 16. It doesn't necessarily look like that is the height, but of course that height could be equal over here as well. They just put it in the middle so that it wouldn't be so messy. So 16 times 33 makes 528. My ball, Mama. I don't have your ball. All right. Then we're going to subtract the area of the circle, which is pi r squared. And so we have pi, but we don't necessarily have our radius because the entire diameter is 16. And so if the diameter is 16, then the radius would be 8. And so we have 8 squared, which means that the area of our circle is going to be pi times 8 squared. And so the entire area is 201.06 for that circle. So the total area comes from 528 for the rectangle, and then subtracting out 201.06 in order to get an entire rectangle, or sorry, shape area of that concave circular end shape. And so we get 326.94, and we are using feet and of course talking about area, so that's squared. All right. So as long as you kind of have followed along in each of the chapters before, remember that this one is pretty much just using each of those shapes from before and then combining them or subtracting them. So that is your 10-3 composite figures note.